Hello students, in the last section or in the last video we discussed about the different types of motion, and in the different types of motion how the coordinates changes in one dimension, three dimension, in two dimension and three dimensional motion. Next, in this video we will discuss about some of the physical quantities or some of the parameters used in kinematics to know the state of a body or a particle. So, to know the state of a body or a particle, we use different kinematic parameters, and I already told that kinematics is that branch of mechanics which deals with the motion of a body without considering the cause of its motion, So, the different kinematic parameters or physical quantities required to know the motion of the body we will discuss in this section. So, one of the most important parameters is the distance. So, what do we mean by this distance? So, this is a common term generally we are using in our day-to-day life. I cover this much of distance. Today I travel this much of distance, like that. So, means the length of the actual path. It is the length of the actual path. What is the length of this actual path traveled by a particle or a body between the initial and the final position, positions in a given interval of time, So, we can say that the distance is the length of the actual path traveled by a particle between the initial and final positions of the particle in a given interval of time. Means there is an initial point where the particle starts its motion, and there is a final point where it reached. In doing so, it takes some time. Naturally, it takes some time. So, in that time interval, how much the length of the path, length of the path or actual path we can say here, covered by the body. That is called as the distance. For example, let us consider a body starts from point A. A particle starts from the point A. Now it goes to a distance B in some time interval. So, let this distance it covers 15 meter. Then it goes to another point in this direction to C. Then it reaches at the point C. So, let this covers a distance of 10 meter. Then if I will ask you what is the distance traveled by the particle in the time interval, suppose to move from A to B, it takes 3 minutes. From here it takes 2 minutes. Then what is the total or distance traveled by the particle in 5 minutes? So, there is the initial point and it reaches to the final point C. So, the distance is the 15 plus 10. So, the distance is equal to, the distance traveled by this particle is equal to 15 meter plus 10 meter, that is equal to 25 meter. So, this is the distance traveled by the particle in this 5 minutes. Okay. So, this is called as the distance. Okay. Now, it is measured, as you know, what are the units? The units of distance are the units, generally we are using the units, as you know, in SI or MKS it is measured in meter, in CGS centimeter, in CGS it is a centimeter, and sometimes we are using the common, that is the kilometer, we are using kilometer. We can say that is practically generally we are using this kilometer for long distances traveled by a body, long distance traveled by a body. Okay, then this distance is a scalar quantity. This is a scalar quantity. It is a scalar quantity because it has only the magnitude without any direction. We are not bothered about in what direction the body is moving or like that. From the initial point, what is the actual path traveled by the body to reach the final point? That total path is the distance. We are not bothered about in what direction it is moving or in what way it is moving from the initial to the final point. Clear? Then the distance traveled by a particle or a body in a given time interval is positive. It is always positive. The distance traveled by a body in a given time interval is always positive. Clear? So the distance traveled by a body is positive. Positive means what? It will never negative. So we will never say that I cover minus 5 meter. Always, if the time passes, we will cover some distance. So my motion is there. If the body is at rest, then you can say the distance traveled by the body is 0. So we can say that it may be the distance traveled may be positive or it may be 0. For 0 case, the body is at rest. When the body is at rest, we can say that it is at it covered 0 distance and the distance is always positive. Is that clear? So now the distance traveled by our vehicles is measured by which device? The distance traveled by our vehicles is measured by, it is there in the vehicle, that is the orometer. The orometer measures the distance traveled by the vehicle. Okay, and this orometer is fixed in the dashboard. When you see the bike dashboard where the handle is connected, handle is there, at the dashboard you will find this orometer. Is that clear? So this is about the one of the parameter in kinematics or a physical quantity used in kinematics, that is the distance. Then the most important another one is the displacement. What is this displacement? And remember, the distance and displacement both are different things. But while discussing the unit and dimension part, there we said that yes, the dimension of distance and displacement are same, but physically the concept is different for distance and displacement. So it is the shortest distance. We can say that it is the shortest distance from the initial to the final point. From the initial to the final point. That is called as the displacement. The shortest distance between the initial to the final point is called as the displacement. And this displacement, the shortest distance means what? There in case of distance, we told that it is the actual path traveled by the body. But here it is called as the shortest distance. So what is the shortest distance? Let us take an example. So let a particle starts from the point A and it goes to the point B and it covers a distance of suppose say 15 meter in 3 minutes. Then in 3 minutes it moves from A to B and the distance traveled is 15 meter. Then from B to C it goes to B to C. From B to C. Then suppose this is the 10 meter and the body took the time as 2 minutes. It takes 2 minutes. So now the displacement is what? Displacement in this case, when I ask you what is the distance, you will tell that what is the distance? 15 plus 10. It is not concerned with your direction. But here the shortest distance from the initial to the final point. So this is the initial point where the particle starts its motion and this is the final point where it reaches. So the shortest distance means we can say a straight line joining the initial to the final point. That is the shortest distance in your geometry. Already we read that the shortest distance is the line joining from the initial to the final point. And this is the unique path. This is the unique path from the initial to the final point, which is shortest. And except that no other point or no other line can join from A to C to get a shortest distance. So that A to C, this gives you the displacement of the particle, the displacement of the particle. So that's why it is called as the shortest distance from the initial to the final point. Okay. So now, then if this is it concerned with the initial to the final point, so obviously this is a vector quantity. This is a vector quantity. Vector quantity in the sense it has magnitude. Magnitude means it has some magnitude means it has size, and it has a direction. So it is a vector quantity having magnitude and direction. Magnitude and direction, and it obeys the laws of vector addition, and it obeys the laws of vector addition. Is that clear? Then the unit of this one, what is the unit of this? As in our unit and dimension discussion, we know that the distance and displacement both have same unit and same dimension. So in SI, here also in SI, or in M case we can say, or in M case the unit is meter, and in CGS the unit is centimeter. The unit is a centimeter, and the common, we can say this is a practically generally for long distances we are measuring the unit as kilometer also. We are measuring that in a kilometer. Okay. So this is about the displacement. Now, next we will find how to calculate. In the example I have given that the displacement is from the initial to the final point. Now, practically how we will measure this displacement, and in different cases, in different examples, how we will measure the displacement, we will go for an example. Now let us consider an example like the particle starts from the point O and reaches to the point A, and the distance traveled is x1 in a time interval t1. In a time interval t1. Okay. Then let in the same path it travels again another time interval t2. We find that the particle is at the point B and it covers a distance of x2, and the time taken in this case is t2 from O to B. So in this path traveled, in these two positions, as the displacement is what? It is the shortest distance from the initial to the final point. But in this case, if I ask you what is the shortest distance the particle has covered, so the displacement, it gives you the shortest path from the initial to the final point, and I find here the particle starts from O, reach at A, and then it be in a time t2. So if I will ask you what is the displacement of the particle in the time interval t2 minus t1, because at t1 the particle is at the point A, and at t2 the particle is at the point B. At the time interval t2 the particle is at the point B. So when the time, what is the displacement of the particle in the time interval t2 minus t1? So the displacement, I can write this displacement of the particle. Displacement of the particle in the time interval, in the time interval t2 minus t1 is given by what I will show that can be shown as a delta x. Generally you can show that as a delta x. What is the delta x? That delta x is equal to, as we know, the shortest from the initial to the final in the time interval t2 minus t1. So this is the initial and this is the final. As the shortest distance is a straight line joining these 2 points, I already told that this is the shortest distance. So I can write this is equal to x2 minus x1, or you can say this is the final distance minus the initial distance. Okay, so in that concept, so we can say that a change in the position of a particle, in a particular direction, so the change in the position of a particle along a particular direction in a particular time interval is also called as the displacement. Okay, and as you already know that the displacement is a vector quantity. It may be negative, positive or 0, because for a vector quantity you can get the 3 values. It may be positive, negative or 0. So now we will discuss about when the displacement is positive and when the displacement is negative and the displacement is 0. So now we will go for the positive displacement. What is this positive displacement? So in the same example, if you go through the same example, so the positive displacement is that in the same example, let me show the same example. A particle in a time interval t1 starts from t equal to 0 to t is equal to t1. It covers the distance x1. Then at time t is equal to t2, it covers x2 distance from the, we can say this is the origin where we are observing all these incidents. That is also called as the frame of reference. We can say here is the frame of reference. You are standing at O and you are observing the position of the particle. Okay. So now as you know, the displacement I can show this delta x is between the time interval t2 to t1. The delta x is equal to x2 minus x1. So in this case, positive displacement means x2. For positive displacement, x2 must be greater than x1. Then if x2 is greater than x1, then the displacement is a positive. Then the displacement is a positive. Is that clear? So this is about the positive displacement. Yeah? Okay. Now for negative displacement, how we will explain this negative displacement? For negative displacement, let us take the example like this. A particle starts from O, it goes to the point A at t is equal to t1. It reaches at the point A, and the distance traveled is, suppose your initial is x1. Now what happens? The particle from A comes to another point B and it changes. So it is the second point is B. It comes to the point B from A to B. At B, it goes along the same path. And come back, and it reaches at B at time t is equal to t2. At B, the distance is from the observer is x2. Okay. Then, as you know, the displacement delta x, we can write this displacement is x2 minus x1. The displacement is the formula is final. What is the final? From the observation to the initial in the time interval. So this is the final distance minus the initial. So that is the formula. But in this case, here this x1 is greater than x2. So x1 is greater than x2. In this case, this x1 is greater than x2. So if x1 is greater than x2, then displacement is negative. Displacement is negative. x2 minus x1. So here x1 is greater, so a smaller quantity minus a greater quantity, you will get the displacement as negative. So, okay. So in this case, as you find here, in negative displacement, it covers initially at t1, it covers a long distance, then it comes back to the position B. So that gives you the negative displacement. And the zero displacement, if the particle is at rest, or the particle starts from the initial point and reach to the again to that point, means what? In this case, the particle either at rest, then the zero displacement, how we explain this zero displacement? For zero displacement, we can show that zero displacement is, suppose the particle starts from A or from the point O and reach at A in time t is equal to t1. Then again from A to B it comes to the point t is equal to t2, again it comes back to the point O. So from where it starts, it comes back to the same position. It may come to the same position along this path, or it may come along this path to reach at the point O. Suppose it comes along this path and reach at the point O. From where it starts, t is equal to 0. It starts from t equal to 0, reach at A in t1, then at t2 it again comes to the point 0. So what is the displacement I realize? The displacement is zero displacement. The displacement is 0. So in this zero displacement, delta x, as you know, x2 final minus initial. Remember always, displacement is the final minus initial we are making, x2 minus x1. So in this part, when this x2 is equal to x1, then if delta x2 is equal to x1, then delta x is equal to 0. So this gives you the zero displacement. Okay. Then these are about the types of displacement. We can say it is a negative, positive or zero. So always remember, a vector quantity can take values positive, negative or zero, but a scalar quantity always takes the, a scalar physical quantity always takes the values of positive in the distance case, as it is always measured in a positive value, because as the time passes it always covers some distances, so the distance is positive, and if it is stationary or at rest, then it will be 0. Similarly in zero displacement also, if the particle is at rest, then we can say the displacement is 0. Okay. Then next is the displacement of a particle in the given time interval does not depend upon the choice of the origin. Means the next point you can say that there are some characteristics we can say that the displacement does not depend upon the choice of origin. What it means, choice of origin, because it is always concerned with the final and the initial position. It is always concerned with the final and initial position. So in this case, when you measure the displacement of a particle, it does not depend upon the choice of origin. It means, suppose you start from O, let you start from O, and at time t1 you reach at x1, it covers a distance x1 initially, then at B, at time t2, it reaches at the point B, that is x2. Then in this case, if this is the coordinate system, if it is in the frame of reference and this is the origin, if you consider in a Cartesian coordinate system, if you consider this is the origin and this is the along x-axis and suppose this is the y-axis. So now in this case, the displacement does not depend upon the choice of origin. Suppose your origin is here, you are standing here, suppose you come to this point O dash. From here if you measure, obviously this distance is not x1 and this is not x2, but delta x remains same. What is this delta x? This is the delta x. You are finding the displacement that gives you the delta x. So the displacement is fixed. the displacement is fixed. Means origin changes means obviously suppose this distance it is not x, so if your origin changes, so this distance is minus, this is not here because this is the origin, here this is suppose your x initial, this is the x initial, and obviously this will be the x final. But if you find what is the displacement, then xf minus xi, that's will this value you will get only this distance traveled, and that is the displacement, isn't it? So the displacement does not depend upon the choice of origin. Next, then we can say that the magnitude of the displacement of a particle between any 2 points equal to the shortest distance. It is the shortest distance between them. The shortest distance between them means, suppose you find it is the shortest distance, it is the shortest, as in the definition, it is the shortest distance between any 2 positions, between any 2 positions. Means if a particle is moving along this path O to A, and suppose it goes to the point B, then if I ask in initially a time t1 interval, it goes from O to A, then from A to B in time t2, then the time interval to reach at B is suppose t2. Then if I ask you what is the shortest distance, that will give you the displacement, and this is the displacement, this will be the displacement, that shortest distance, and this displacement is written as delta x, and this is obviously a vector quantity from the initial to the final, from the initial to the final. So this is the displacement. Clear? So it means it is the shortest distance between any 2 positions between the O to A, from the initial to the final. Clear? So this is the displacement, and is directed from initial towards the final, that is the displacement. Okay, so this is the another characteristics we can say about the displacement. Then if I give you an example here, suppose a particle moving in a circular path complete one revolution. Suppose a particle cover one complete revolution in the circular path, and it starts suppose from here, and then it comes rotate in the circular path and reach at the same point. Then if I will ask you, and let the distance, the radius of this circle is the circular path, the particle travel is suppose r. So what is the displacement of the particle? So the shortest distance between this initial to the final, between the 2 points, and the initial and final point is coincide at the same point, or if they coincide, then the displacement in this case is 0. The displacement is 0. And what is the distance if I will ask you? Then you can say that yes, the actual path covered, and this is the actual path covered. What is this actual path? That is the circumference of the circle. And what is the circumference of this circle? That is equal to 2 pi r. So this is the distance, and the displacement is 0. The displacement is 0 because both the points coincide. Similarly, if I will ask you for a half circle, if the particle starts from here, not at this point, suppose the particle starts from this point O and moves along this path, or from the point A and goes reach at the point B along this path, half circle, and obviously r is the radius of this one. Then what is the distance of this covered by the particle? The distance is this path from A to B. So this is your pi r, half of this circumference. And what is this displacement? The displacement is how much? From this. This is the shortest distance from the initial to the final. So it is directed like this from the initial to the final. So the displacement is equal to what? R. Suppose this is the origin, R, or origin of the circular path, r plus r. So he will say that it is 2r. So this is the shortest distance between any 2 positions of a particle. Okay. Now next we will go for the another characteristics of this displacement. The displacement of a particle between any 2 points does not give any information about the shape of the path followed by the particle. Shape of the path followed by the particle does not give any information. It does not give any information of the path traveled. Any information of the path traveled by the particle. Means, suppose a particle starts from A, it goes to the point B. It can go along this path like this, or it may go like this, or it may go along this path like this to reach at B. So, we are not concerned about in what path it travels. If I will ask you what is the displacement, you will say that this is the displacement. This path is this length is the displacement, initial to the final. It does not give any information of the path traveled by the particle. Okay, so this is another characteristics of displacement. Okay, then the magnitude of the displacement of a particle. Remember, this is very important. The magnitude of displacement, because it is a vector quantity. The magnitude of displacement of a particle, the magnitude of the displacement of a particle is equal to the distance traveled by the particle. Is equal to the distance traveled by the particle. Distance traveled by the particle is equal to the distance traveled by the particle. And if the particle moves along the straight line path, if the particle is along a straight line path, that is most important. Along the straight line path, if the particle travels along the straight line path, then the magnitude of the displacement is equal to the distance traveled by the particle. Now, if you show this one, if it is not a straight line, then what happens? Then if it is straight line, then how it is seen? Now, in this case, you can say that let a particle starts from A and let it goes to reach at the point B in the straight line path. So, if I ask you what is the distance, here the distance is AB. The distance traveled is AB. Then what is the magnitude of this displacement? Because displacement is a vector quantity, we are not going for the direction. So what is the displacement of the particle? The line joining from the initial to the final point. And this is the straight line which joins from initial to the final point. So this is displacement, the magnitude of the displacement, you can say that magnitude of the displacement is like this, AB magnitude. So this is the most important. The magnitude of our displacement is equal to the distance traveled by the particle if the particle is along a straight line path. If the particle is not along a straight line path, so in that sense, we can say another thing is that the displacement of a particle is always less than or equal to the distance traveled by the particle. Means you will never find that displacement is greater than the distance traveled by a particle, because the shortest path is the straight line joining from initial to the final. So the displacement is always less than if it moves in any other path A. Suppose it reaches to the point B. So in this case, this is the distance, and obviously this is greater, but the shortest is, this is the unit path, this is the displacement. So the displacement is always less than or equal to means in this case, and in any other case it is always less than the distance traveled by the particle. Okay, so in this discussion we know about the distance and displacement of a particle. Then if I ask you differentiate between distance and displacement, then you can, by combining all these factors, you can differentiate the distance and the displacement. Okay. Then next we will go for another physical quantity associated in kinematics, that is our speed. Okay. So what is the speed? We can say the speed is the how much distance traveled by a body per unit time. Distance traveled by a body per unit time, that is called as speed. So the distance traveled by a body per unit time, the distance traveled by a body, the distance traveled by a body per unit time. Per unit time means divide. Per unit time is called speed. Means you can write the speed is equal to, mathematically you can write the distance traveled, how much distance it traveled. Then you take for unit time, means you divide this time. Means in 5 seconds I traveled 20 meter. Then what is my speed means the total distance traveled is 20 meter. In 5 seconds, divide with 5 seconds, so it will give you per unit time. That's why this is the distance traveled by the time taken, you can say, or the what is the time taken by the particle. Okay, and as the speed is expressed, the units are meter per second, kilometer per hour, you can say, or centimeter per second. Like that you can express the speed in different systems of unit. In M case a meter per second, in CGS kilometer per second, but in practical you can use also kilometer per hour. Okay, then remember 1 kilometer per hour, that is always the conversion is required. 1 kilometer per hour means what? And if you express that in meter per second, 1 kilometer is equal to 1000 meter and 1 hour equal to 3600 second. If you express that in your MK system or SI system, then this is equal to, these two get cancelled, this 5, 2, 5 is 10 by 18, 5 by 18 meter per second. This conversion is required. And the speed is a scalar quantity, it has only the magnitude. The speed is a scalar quantity, it has only magnitude, or you can say it has only the size. And no, it has no direction, because a scalar quantity has no direction, so it has no direction. And it is always, as it is a scalar quantity, it is always positive and it can never be negative, because the distance is never negative, because speed is distance by time, distance is never negative, so speed is also never negative. And as you know, time is never negative, you cannot go for negative time, so both are positive, distance and time, so the speed is also positive. Okay, then you will come across different types of speed, or you can define these different types of speed. One is called as the uniform speed. What is this uniform speed? Uniform. Anything has form, then that is called as a uniform. So means a uni means a unique form, that is the uniform speed. A particle is said to be moving with uniform speed if it travels equal distance in equal intervals of time. Then the speed is called uniform speed. Means if a body or a particle travels equal distances in equal intervals of time, however small time intervals may be. However small these time intervals, that is important. However small the time intervals may be. The time intervals may be. It means what? Suppose if you see an example here, suppose a body starts from A, reach at the point B, the distance traveled is 5 meter and it takes 1 minute. Then from B to reach at the point C, the distance traveled is 5 meter and the time taken is again from B to C is 1 minute. Then from C, it reaches the point D, the distance traveled is 5 meter in 1 minute. Then if I will ask you, what is the speed of the particle to move from A to B? That is 5 by 1. Then from B to C, 5 meter by 1 minute. Then from C to D, 5 meter by 1 minute. So this is 1 minute, or you can take the second also. Let us take second, so it is clear. So in this part, what is the speed from A to B? 5 meter per second. From B to C, that is 5 meter per second. From C to D, 5 meter per second. So in this intervals, the speed is 5 meter per second. Here is 5 meter per second. Here is 5 meter per second. So this is the speed is called as the uniform speed. And if you see, if you plot a graph of this uniform speed, the distance traveled with respect to the time. So let the particle takes 3 minutes. Let me show for the 3 minutes. If you plot a graph, suppose this time t is equal to 0. Here time is equal to 1 minute. 1 second. Time is equal to 2 seconds. So this is the time axis along as this, and this is the distance s. Let me show the distance as a s. So 1, 2, 3 like that. Then let this as the 5 meter, 10 meter. This is equal divisions in the graph. So at 1 second, it has a distance travel as a 5 meters. So it is goes this at the point. So here the time is 1 second. It is in second. Then this distance is in a meter. Clear? So in 1 second, it reaches at a B. So the distance is 5 meter. From B to C means from A, if you consider from A to C, the total time taken is 2 seconds. And what is the total distance? 10. So in 2 seconds, I can say it is reached at the 10 point. 10. Then 3 seconds, it is at 5. 15. Means 5 plus 5 plus 5, 1 plus 1 plus 1. In 3 seconds, it is a 15. So if you join that, you will get a straight line like this. You will get a straight line. So for uniform speed, you will get a straight line. And when the body is in uniform speed, then what you are finding here, that in uniform speed, the distance traveled by the body is proportional to time. Distance traveled is proportional to time. How much the time increases? 1 to 2 seconds, 5 becomes to 10. Then 1 becomes 3 seconds, 1 at 3 seconds, 5 becomes 15. So distance traveled is proportional to time. In 1 second, 5 minutes. 2 seconds, it is 2 times, it is also 2 times. It is 3 times, this is also 3 times. So that's why it is a straight line. The equation is a straight line. Okay. Then next we will go for a variable speed. So this is the uniform speed. Then what is a variable speed? Just opposite. Variable speed means what? If it travels variable speed means, in case of variable speed, you can say if a particle travels unequal distances in equal intervals of time, if it travels unequal distances in equal intervals of time, or the other may be, or the travels equal distances in unequal intervals of time. That is also true. Okay. So if it travels or equal distances, I am not writing in detail, you will get the notes, equal distances in unequal intervals of time. Means what? In this case, take an example like that. For the first one, let me show you a example like that. Suppose a body is moving like this, starts from A, reach at the point B, in time t is equal to 1 second. Suppose the distance is 2 meter. Then at time t is equal to 2 seconds, after 1 second, I find the particle is at C, and from B to C, the distance travel is suppose 3 meter. Then after time t is equal to 3 seconds, at t is equal to 3 seconds, the particle is at D, it covers 1 meter. From C to D to 1 meter. Means in this equal intervals of time, the distance traveled by the particle in 1 second, the distance is 2 meter. But in 2 seconds, how much is the distance? That is a 5 meter. The distance is 5 meter. In t is equal to 3 seconds, how much the distance? 3 plus 2 plus 1, 6 meter. So it is increased in 1 second, it travels 3 meter extra, and then rest 1 second it travels 1 meter. So there is not a uniform, means unequal distances in equal intervals of time. Or the other case may be, suppose 2 meter, and the same 2 meter from B to C it travels, but it takes t is equal to 3 seconds. When I find at C, when the time is 3 seconds, it covers this 2 meter. Then at that time 5 seconds, or suppose at the time 4 seconds, it covers again 2 meter. So here in this 1 second it travels 2 meter, then here in 2 seconds it travels 2 meter. Here in 1 second, again in 1 second it travels 2 meter. So here it is unequal. Yes, it is equal. In this interval it is travels in equal interval of time, t is equal to 0 in 1 second. In these two cases it travels the same distance, but here it is not the, in 2 seconds it travels 2 minutes. So the speed is called as a variable speed. Okay, so in this case, so the example you can say that in this example variable speed, in our day-to-day life you are coming across the variable speed. When you start from your home and you reach at a place, or by a bus you are traveling from your home to another place, then the bus is in uniform speed, is a non-uniform speed, or you can say that is a variable speed. That can be called as a variable speed. That is also a non-uniform speed or a variable speed. So the distance traveled by the body is not directly proportional to the time. Here the distance traveled by the body is not directly proportional to the time in case of variable speed. Okay, so when the body travels a variable speed, then if I will ask you, what is the, suppose the body starts from A and reaches at the point B, but these are the paths, these are the body is in variable speed from A to B. For example, you start from here, from your home, and you reach to another place nearby, and during that path, during this total distance traveled, you have covered in different time intervals different distances. Means first 1 hour, suppose you travel for a 3 hour from your home to a tourist place, okay, nearby tourist place. So that to reach from your home to the tourist place, it took you 3 hours. During these 3 hours, your speed is not uniform. Obviously your speed is not uniform. You are traveling by a bike, you are traveling by a bike or by in a bus. So the bus is not moving with a uniform speed throughout the path. So in that case, if you find the speed, then if you find the speed from initial point to the final point, how much time it 3 hours, in these 3 hours your speed is not uniform. Your speed is not uniform, means you are not moving with a 5 km per hour or a 50 km per hour like that. So that means that is not a fixed value, you are in a variable speed. In that case we will find the average speed. In that case we are finding the average speed. So what is this average speed? The average speed, to go in case of a variable speed, when a body moves with a variable speed, then the average speed of the body is calculated, and the average speed of a body is defined as the ratio of the distance traveled. It is defined as the ratio of the distance traveled, ratio of the distance, total distance traveled to the total time taken. It is the ratio of the total distance traveled to the total distance traveled to the total time taken. So when you calculate this average speed, I can show this average speed as the average speed. I can say that, let the symbol is, we can say V average. I will show this as V average, or generally this can be written as V bar. This average speed can be written like this, V bar. So V bar, so don't think that this is a vector quantity, because this bar is for average. It is not a arrow mark. If it is arrow, then it is a vector. So I put this bar. V average is equal to, suppose that total distance traveled is delta x. The total distance traveled by the body is delta x in a time interval delta t. In the time interval delta t means from A to B, to reach from A to B, the total distance is suppose delta x, and the body is variable speed from A1 it is from here to here, A to A1, it has a different speed. From A1 to A2, it has a different speed. From A to B, it has a different speed, the variable speed. In that case, but the total distance is suppose delta x and the total time interval is delta t. In this case, the total time interval is delta t. Then the average speed is equal to delta x by delta t. So here, this delta x generally, this delta x should be equal to what this then delta x in this. When you calculate this average speed, the delta x is obviously the final position minus the initial position. Final distance to the initial distance from where it starts and where it reaches, except the total distance. Here the distance, it is not the position. So it is the final position to the final distance traveled to the initial distance or initial position. Okay. Then from here, if this is the average speed, then we can go for then the body is in average speed. So in this case, if I will ask you, so in this total path, suppose I will ask you, what is the speed of the particle at this point? Suppose at this point, suppose this is the O is the position. At this point O, when the body moves with a variable speed, and you know the average speed, but if I will ask you, what is the speed of the body at the point O, when it passed to the point O? You are traveling from your home to the picnic spot, but during your path, when you start from your home at 10 a.m. and you reach there at 1 p.m. It takes 3 hours. But if I ask you, at the time t is equal to 12:45, what was your speed? Means I am asking at a particular instant, what is your speed? So in that case, we will not consider this average speed. In that case, we will take the instantaneous speed. So in that case, we will consider the instantaneous speed. In that case, we will consider the instantaneous speed. So instantaneous speed is what? When a body is moving with variable speed, then the speed of the body at any instant of time is called the instantaneous speed. And what is instantaneous speed? In that instantaneous speed, for considering the total time delta t for 3 hours, I will make the time smaller and smaller, and I will make a smaller, very smaller time interval. Means in that case, we can write this as a limit, the instantaneous speed, you can write b, simply b is equal to limit delta t tends to 0. It is not 0, very particular instant, means it may be very smaller interval. The total time is delta t. If I make this smaller the time, so I can go to reach at that instant O. Means I will make this smaller, this side also smaller, so I can reach to this instant. So in that instant, how much? Obviously the distance is also smaller. So limit delta t tends to 0, what the average speed delta x by delta t. And in derivative concept, you know that this can be written as dx by dt, right? So this is a very small distance traveled by the very small time interval. So this is the called as the instantaneous speed dx by dt. And the average speed of a body is equal to the instantaneous speed if the body moves with a constant speed. If the body has a constant speed during its path, if the body has a constant speed during the path, so constant speed means what? The body is moving with a uniform speed. For uniform speed, the average speed is equal to the instantaneous speed. Means throughout this total path, what is the average? That you will get as the instantaneous. Okay, and as you know, this instantaneous speed is measured by the speedometer. In our vehicles, we are measuring this instantaneous speed, that is by the speedometer. So in the vehicle, when you are moving, the speedometer shows you at a particular instant what is the speed. Now it is 40, then 30, then 50, like that. That is the speedometer measures the instantaneous speed. Now let me go for some of the examples to know calculate the average speed. Now let us calculate the average speed, and generally we will find this in problems, in applications, to calculate the average speed. Suppose a body traveling different distances with different speed. So let a body travels, I will not write in detail, let a body travels a distance s1 with a speed v1 and another distance s2 with a speed v2. So the body travels s1 distance with speed v1 and distance s2, the same body travels a distance s2 with a speed v2. So body traveling different distances s1 and s2 with different speed. So this is a case like that. Suppose you start from your home and you cover a 5 kilometer with a speed of 10 kilometer per hour, then next 13 kilometer different distance 13 kilometer with a speed of 18 kilometer per hour. So that is the case like this. So in this case, now we will find what is the average speed. So in that case, as you know, the average speed is equal to the total distance traveled by the total time taken. So you have to calculate the total distance and what is the total time taken. And obviously you know that the total distance traveled is how much here? Total distance. The total distance traveled is equal to S1 plus S2. That is S1. So the time taken to travel the distance S1, time taken, now we find the time, total time taken. Time taken to travel the distance S1, let that is equal to T1. What is the time taken T1? So time taken is T1 is equal to, what is the formula? That is S1 distance by V1 by the speed, because speed is equal to distance traveled by time, right? Similarly, the time taken to travel the distance S2, T2, let that is T2. What is the T2 I will take? Then the distance S2 traveled with a speed V2. Total time taken is how much? Total time taken to travel what? The distance S1 and S2. Total time taken is equal to T1 plus T2, that is equal to S1 by V1 plus S2 by V2. Yes? Then now I will find here the average speed. Remember the formula. Average speed, V average, or we can write V bar, that is equal to total distance, that is your S1 plus S2 divided by T1 plus total time taken T1 plus T2, that I can write this as T1 plus T2, that is equal to S1 plus S2 divided by, what is T1 by T2? That is S1 by V1 plus S2 by V2. So this is my average speed. So this is the formula for the average speed when the body is different distances in different speed. So if there are three distances travel in 3 time intervals it is given, then for 3 cases also you can take V average equal to S1 plus S2 plus S3. How many distances are traveled divided by S1 by V1 plus S2 by V2 plus S3 by V3 plus dot 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 plus dot 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 like this. So this will give you the V average. Okay. So this is the V average of the body. Okay. Suppose in this case, if I do like that, if the body travels equal distances with different speed, equal distances with different speed, equal distances with different speed, then I can write what? The average speed. Equal distances with different speed means, equal distance means S1, S2, S3, all are same like that. For 2 cases I will take for different distances. So S1 is equal to S2, that is suppose S. Equal distances with different speed. The different speed is for V1, for S1 distance means for S distance speed is V1, for again S distance speed is V2, means for 5 kilometer the speed is 5 kilometer per hour. Next for another 5 kilometer the speed is 12 kilometer per hour. So the speed is different but the distance traveled is same. In that case if you find the average speed V average equal to what you will get here. For this is S, means this is 2S divided by S plus S 2S divided by S by V1 plus S by V2. So this S get cancelled, so you will get this is equal to 2 by 1 by V1 plus 1 by V2. Or you can write this is equal to 2 into V1 V2, isn't it? 2 into V1 V2 divided by V1 plus V2. So this you can say that the average speed. So 2 into V1 V2 by V1 plus V2. For three cases, you can do this as a homework. For three cases, what you will get? You put like that: S1 is equal to S2 is equal to S3, that is equal to S, and the speed is V1, V2, V3. In the three, for the body that travels equal distance have the speeds V1, V2, V3 respectively. Then the average speed I can write this as you can do that as your homework. 3 V1, V2, V3 by V1 into V2 plus V2 into V3 plus V3 into V1, like the sequence is there, V3 into V1. Okay, so this is the case. Okay, next I will go for another example, another way of calculating the. Next, another example we will go for a body moving with different speeds in different time intervals. Let us consider a body moves with various speeds V1, V2, V3 respectively. The time intervals are T1, T2, T3 with different time intervals. In time T1, for a time interval T1, the speed is V1. For a time interval T2, the speed is V2. For a time interval T3, the speed is V3. So, body moving with different speeds in different time intervals. In that case, how we will calculate the average speed? So, as you know, from here, the total distance covered is how much? Total distance covered. Now, tell me, what is the total distance covered? Total distance covered, let me take this as equal to, for speed V1, time is T1. So, what is the distance covered in this path? How much in the time interval T1? What is the distance covered? V1, T1. Then in this case, for time interval T2, what is the distance covered? V2, T2. Then for the next, it is V3, T3. Like that, you can go for number of, what is the different speeds for different time intervals given, you can multiply like that, because speed into time will give you the distance traveled. Then that is the total distance traveled, and already you know that the total time taken, it is given, total time taken, that is given to you, that is equal to T1 plus T2 plus T3. So that is the total time taken. Then now I will write this average speed, V average is equal to total distance traveled V1 T1 plus V2 T2 plus V3 T3. I have considered for three cases. You can take number of times what is given, T1 plus T2 plus T3, that is the total time taken. So this is the formula for calculating average speed for a body moving with different speeds in different time intervals. Suppose the time intervals are same, that is a special case, you can say that. The time intervals are same. Suppose T1 is equal to T2 is equal to T3 is equal to like that, suppose T. So, body moving with different speeds in same time interval. So, in that case, if you put that, here V average is equal to, all are same means we can take this T common, because T1 is equal to T2 equal to T3, that is T. So, this is equal to V1 plus V2 plus V3 divided by T1 is T, that is equal to 3T. So, that T get cancelled, right? So, you will get V1 plus V2 plus V3 by 3. So, means for a body moving with different speeds in the same time interval, you can find the average speed is equal to, what the average speed you will find in this case? V average is equal to V1 plus V2 plus V3 by 3 for three cases. If there are n number of cases are given, V1 plus V2 plus V3 plus up to Bn divided by n. So, these are the ways of calculating the average speed for different cases. Okay, students, thank you.